Okay, Math 3, we are going to take a look at section 512, equations with fractions and decimals and fun things like that. To start off, I want to do a couple of quick calculations here. So with a calculator, if you like, or in your head if you're good at it, go ahead and do all of the problems you see right up above here. And when you're ready, you can come back. So pause the video and then come back to check when you're done. All right, so 0.3 times 10 was 3. 0.28 times 10 was 2.8. But 0.28 times 100 was 28. Interesting. Here, 3/5 times 2 is 6/5. 3/5 times 3 is 9/5. But 3/5 times 5 is 15/5, which reduces to 3. So what we're looking at here is that sometimes if you multiply a fraction or a decimal by just the right number, you can turn that fraction or decimal back into something whole. So here, 0.3 times 10 was enough to turn 0.3 into a whole 3. Over here, it needed to be 100 to turn 0.28 into a whole 28. And here, it needed to be 5 in order to turn 3/5 into a whole. We're going to use that idea then to rewrite equations to make them easier to solve, especially if you didn't have a calculator. So let's take a look at problem 511. Part A has this equation. Now you notice that every number in the equation has a point something. There's only one digit after the decimal point for every number in this equation. Well, up above, when I had one digit after a decimal point, all I needed was to multiply by 10 to make it whole. So what I'll do down here is I'm going to take the entire equation and I'm going to multiply every single thing by 10. And I'm allowed to do that. As long as I do the multiplication to every single term in the equation, I'm allowed to do that. So a 2.1 would become a 21. A 0.6 would become a whole 6. And a 17.4 would become a whole 174. See, the beauty of this now is that I can go ahead and I can solve this equation. Even if I use my calculator, I can still solve this equation with a little bit easier work. So I'll subtract 6 from both sides. And then I'm going to divide by 21. Turns out I get a nice whole number of 8. Now, if I had a calculator, could I have just subtracted 0.6 and divided by 2.1? Yes. But our idea today is to see if we can find ways to make it easier. So let's look at this one. This one, the problem is all my numbers are awfully big. But did you notice that every number in this problem ends in a 0? Well, that means that I could really divide everything by 10. So I could actually almost like cross off a 0. And that's only because every single number had an extra 0 to give. Now I can go ahead and do it. I can subtract the 25, and then I can divide by the 10, and either leave it as a decimal, or I could make it a fraction, depending on what we want it to be. All right. Now, decimals and whole numbers that are big, those are easier. But let's think about fractions. Now here I have a fraction that is a 2x over 3. The part that's really annoying is the over 3. Let's go back up to the top. When I needed to get rid of a denominator to make a fraction go to a whole, take a look at the number that was needed. It looks like multiplying a fraction by its own denominator is what will turn it back to whole. Okay, so then I am going to go through and I'm going to multiply everything in this equation by 3. Now, when I do that, I am going to get, so times 3, 6x over 3, and over here, I'm going to get 90. Well, 6x over 3 divides to 2x. And then if I divide by 2, I get my answer of 45. Let's look at the same thing over here. So I have x over 5 plus 1 equals negative 6. I think the first thing I'm going to do is subtract that 1, because everything is integers there. Since I have a denominator of 5, I'm going to multiply by 5. So that would give me 5x over 5 equals negative 35. 5x over 5 is just x. And I get x is negative 35. Now that's great. And you might be thinking, sure, nice and easy. Yeah, except what happens if there's more than one denominator? Oh, all right. Let's talk about that. When there's more than one denominator, there are several approaches you can use. I'm going to show you the one that's going to be most helpful as you move forward in Algebra 1 and Algebra 2. When you have two different denominators, that is going to make this problem unpleasant. So what we're going to do is the very first thing is we're going to make sure that they have common denominators. So that's what we're going to do. We are going to go ahead and get common denominators. There we go. So I have to ask myself, what's the common denominator of 3 and 5? What is the next closest number that I could multiply them both up to? Well, that common denominator is 15. And remember, you might have done this when you were a kid. You would start listing off the multiplications for 3, and you'd start listing off the multiplications for 5, and you were looking for the very first number that showed up on both of their lists. So I need a common denominator of 15. Since this is a whole number, we'll go ahead and leave it alone. So now the question is, if I have thirds and I'm changing to 15ths, what's the scale factor? It's 5. So I have to scale factor my x. When I change 5 to 15ths, what's my scale factor? It's 3. So I am going to scale up by 3. Now that I have this, I have my one single denominator. So now I can multiply the entire equation by 15. Sometimes I like to write it up above. I mean, it is going to multiply to the numerator anyway, so sometimes it's helpful to do that. And I get 75x over 15 plus 45x over 15 equals 240. Now 75x over 15 is 5. Wait a second, hold up. The answer ends up just being the numerator? No. Yeah, because 45 divided by 15 is 3. Oh, that's interesting. I could have saved myself some grief and some extra multiplication. Huh. So I'll add my like terms, and I'll divide by 8, and there we go. Now we can apply this. Let's take a look at problem 514. I sort of summed up this word problem. It said that Sam was painting the living room of an apartment and it would take him 3 hours, and then Pam comes along and she's like, haha, I can do it in 2 hours. And so Sam's like, okay, if you're so smart, then how about you work with me and we can get it done? Now, first things first, if they're working together, what do we know for sure about this answer? Like, absolutely. If they're both working diligently, what would we have to know? Do you think it would take less than 3 hours to do it? Do you think it would take less than 2 hours to do it? And that right there, we know if Sam is helping Pam, like she's the fastest of the bunch, if he's helping her, we know this answer has to be less than 2 because she could do it alone in 2 hours. With help, it should go faster. So let's come down here and see. This is the equation that models this problem. It's okay if you don't understand where it came from. This is something we do in Algebra 1 sometimes, but really in Algebra 2. So here's an equation that is the model to this word problem. Let's find that common denominator. Let's see, the common denominator of 3 and 2 is 6. So I'm going to scale every fraction in this problem up to 6. Well, if I'm scaling 3 to 6, that x is going to double. If I'm scaling 2 to 6, that x is going to triple. Now I have my one denominator. So I'm going to multiply the whole problem by 6. 6, 6, 6. And remember what we said. When we do that, every fraction will just drop the numerator. So this first one will just be 2x. I don't even have to multiply to get 12x over 6 and then divide. This one is just going to be 3x. This is not a fraction, so I have to do the multiplication. 6. That's where I find it kind of helpful to use a different color on the denominator, because then anything with a different color, I get to do a shortcut. No different color, gotta just do the math. So now add it up, and I'll divide by 5. It would take them 1 1/5 hours, or if you wanted to be really technical, 1 hour and 12 minutes to do the entire painting. So now you've had a chance to see some things with this. Go ahead and pause this video, and I'd like you to go in and go to section 512 and try problem 513. There are 4 problems to try. Okay, if you're back, it's because you're ready to see how this works. So here we go. I'm just going to go through them pretty quick. I'm going to scale up to 21. That'll be 3 A's, and that'll be 7 A's. Now, if I multiply everything by 21, I get 3 A's and 7 A's and 210. So 10 A's make 210. Divide by 10, and A is 21. Now, this problem has 3 fractions. The common denominator of all 3 is 10. All right, so now scaling 5 to 10, I have to double. So 3y becomes 6y. Scaling 2 to 10, I have to do a times 5. So 3 becomes 15. Scaling 10 to 10, well, that's the same, so that stays the same. Now I can multiply through by 10. But remember, anything that has that golden denominator, it's just going to go away. Now I'm going to subtract 6y from both sides, and there's my answer. All right, let's look at C. C has 3 fractions, and the common denominator for all 3 is 6. The first one, no scaling needed, so my 2x minus 3 stays the same. For my second one, I need to double, so my 2x becomes 4x. For my 1/2, I need to triple, so my 1 becomes 3. Now I'm going to multiply through by that 6, and I get 2x minus 3 and 4x plus 3. These parentheses are really not needed, so I'll go ahead and drop them. Now I'm going to see, how about I subtract 4x from both sides? And then I'll add 3 to both sides. And then I'll divide by -2. Well, that's kind of cool. All right, last one, here we go. This one has kind of an unpleasant common denominator. 3, 4, and 5, the closest thing is to multiply them all together to get 60. It's really the best we can do. Now, whenever I have something in a numerator like a b plus 3 or a b minus 2, the first thing I'm going to do is put parentheses around it. I just want to be sure that I know that it's all part of the numerator. Now, to turn 3 into 60, I need to multiply by 20. That means I have to multiply that whole numerator by 20. 20b plus 60. To turn 4 into 16, I have to multiply by 15. So that's a 15b. To turn 5 into 60, I have to multiply by 12. So I have to multiply everything by 12. That's 12 times b minus 2 times 12. All right, yay. Now I'm going to do multiply by 60. And I get the first numerator minus the second numerator equals the third. Anything with the golden denominator is going to just drop out, and the numerator is right there for me. I'm going to combine my like terms. And I think I'll subtract the 5b, because then I'll have positive 7b's on the right. And then I'll add 24. And then I'll divide by 7. So that's problem 513. I know this is a tricky idea, so it's okay if it doesn't feel like it's sinking in right now. We will keep practicing.